Welcome to Fermilab. I'm Harriet Kung, Deputy Director for Science Programs in DOE's Office of Science. It is a pleasure to meet you all today. Today, I want to share my perspective about what makes Fermilab unique and important in advancing the Office of Science mission today, and the exciting opportunities that could help shape the future of the laboratory. Fermilab is America's premier laboratory for particle physics and accelerator research. It is a nexus point for worldwide collaborations and efforts to understand our universe from the tiniest particles to the entire cosmos. The laboratory brings together experts from around the world to advance our knowledge about the fundamental forces of nature, the building blocks of matter, and how the universe developed into its present form. To remain on the leading edge of these pursuits, Fermilab also hosts vibrant efforts to advance the technology that enables breakthrough discoveries, including particle accelerators, instrumentation, and computing. This confluence of bringing together talented people and advanced capabilities in pursuit of particle physics puts Fermilab in a unique position, acting as a center of domestic activities and hub for international collaborations. As many of you know, that CERN, the host of the Large Hadron Collider, LHC, acts in a similar way as an enabling hub of centralized activity in Europe. The strong partnership between Fermilab and CERN benefits both sides of the Atlantic and enables key elements of a successful global program. On this world stage, Fermilab is a recognized leader and balances leading in global competition in some areas with playing critical roles in globally cooperative efforts in others. It is host to a world-class muon campus and building an international flagship neutrino facility. For example, Fermilab is the US lead for the LHC CMS experiment and the leader in superconducting magnet and accelerator technology. It is also a leader in quantum information science and host to a vibrant theory program that inspires new connections between these efforts and new avenues to explore the universe. This leadership is reflected in the role that Fermilab is playing in carrying out the long-term strategic plan presented in the 2014 report of the Particle Physics Project Prioritization Panel, P5. The P5 report provides a strategy and priorities for US investments in particle physics. Within the P5 framework, Fermilab has central roles amongst the highest priority projects, including serving as the host laboratory in selected projects. For the US strategy to be successful, Fermilab must be successful as an international leader, collaborator, and host. One of the P5 project's highest priority goals is providing US contributions to the planned LHC upgrades, including the accelerator and detector upgrades necessary to realize the high luminosity LHC program later this decade. The High Lumi LHC project will extend the discovery potential of the LHC by increasing the number of particle collisions per second to enhance searches for new particles and new forces that could be created in high-energy particle collisions. Fermilab also leads the US High Lumi LHC Accelerator Upgrade Project, which will contribute cutting-edge superconducting magnets and beam manipulating cavities to focus the high-energy particle beams and increase the rate of particle collisions occurring in the heart of each LHC experiment. The US-built niobium-10 superconducting magnet built for LHC have already set a new world record for the highest magnetic field strengths in an accelerator focusing magnet. Fermilab also hosts the High Lumi LHC CMS detector upgrade project, which will enable the CMS experiment to operate in the harsher radiation environment of the upgraded accelerator and enhance its ability to parse the enormous volume of data produced with more collisions. The expertise and capabilities Fermilab brings in detector instrumentation, including silicon detector design, fabrication, and readout, are critical to the success of the CMS upgrade. In addition, the P5 report recommended establishing a US-hosted International Long Baseline Neutrino Facility, LBNF, as the other highest priority goal. LBNF and the Deep Underground Neutrino Experiment, DUNE, will be the first internationally conceived, constructed, and operated mega science project hosted by DOE in the United States, and is currently the largest project in the Office of Science portfolio. Fermilab is the lead laboratory and the host of LBNF DUNE. The world's most intense neutrino beam will be created here at Fermilab and sent 800 miles through the Earth to a detector that will be constructed a mile underground at the Sanford Underground Research Facility in South Dakota. By studying the ghostly neutrino, which rarely interacts with matter, DUNE scientists seek to answer deep questions about the universe, including why matter dominates over antimatter in our universe today. Building a strong foundation for the successful LBNF DUNE project is much more than excavating mines and pouring concrete. It involves establishing and strengthening the international partnerships necessary to realize this ambitious world-leading facility. Maintaining our strong partnership with CERN is critical. The bilateral US-CERN agreement signed in 2015 enabled our strong partnership with CERN at the LHC to grow, to include their support for the US-hosted LBNF. CERN is providing two of the very large cryostats necessary to host the DUNE detector module in South Dakota, while also hosting the CERN neutrino platform, where the International Proto-DUNE experiment tests the detector technology for DUNE. Fermilab also play an important role in building partnerships with UK, France, Italy, and Brazil, paving the way for their in-kind contributions to LBNF DUNE. To foster the development of these collaborations and the R&D necessary to successfully realize the project, Fermilab aided in developing new agreements, including new instruments such as the International Cooperative Research and Development Agreement, ICRADA. Throughout these efforts, Fermilab will continue to play a critical role to strengthen these collaborations while seeking out and finding new partners for LBNF DUNE. In order to create the world's most intense neutrino beam, as well as serve many other experiments hosted here in the future, Fermilab also must successfully upgrade and maintain the Fermilab Accelerator Complex. As an Office of Science National Scientific User Facility, the Fermilab Accelerator Complex provides researchers with one of the most advanced tools of modern science. It served over 1,700 users in the fiscal year 2021 and is poised to grow as LBNF DUNE and other experiments come online in the coming years. Looking to the future, the Proton Improvement Plan 2 PIP2 project will replace the heart of the Fermilab Accelerator Complex with an advanced superconducting radio frequency RF accelerator to provide a reliable, intense proton source to enable the next 50 years of scientific progress. The PIP2 accelerator will be the first built in the US with significant international contributions through key partnerships with Italy, India, France, UK, and Poland. A future booster upgrade will enable the Fermilab Accelerator Complex to deliver even more beam power to LBNF DUNE and other experiments. The Fermilab Accelerator Complex currently serves experiments prioritized in the P5 strategy at the muon beamline and 2 neutrino beamlines. Muons are short-lived, heavier cousins of electrons with about 200 times their mass. The muon campus is home to the Fermilab muon G-2 experiment, which made international headlines when it announced its first results in 2021. Through a precision experiment of the magnetic moment of a muon, With a targeted experimental uncertainty of 140 parts per billion, the muon G-2 experiment will provide a robust test of the standard model of particle physics that may indicate that it could be incomplete. In the coming years, the muon to electron conversion, the mu2e experiment, will search for the spontaneous conversion of a muon into an electron with a factor of 10,000 times more sensitivity than previous experiments in an effort to probe for physics beyond the standard model. These incredibly sensitive experiments have the potential to probe physics far beyond the energy of collisions at the LHC. Let's now switch gear to the neutrino front. The neutrino experiments hosted at Fermilab are not only exploring fundamental questions about the universe, but also building the tools and strengthening the scientific collaborations necessary to realize the future potential of LBNF Dune. The lone baseline NOVA experiment, including a near detector at Fermilab and a far detector 500 miles away in northern Minnesota, is leading the way to better understand neutrino flavor oscillations. The NOVA experiment is setting some of the world's best constraints on properties of the neutrino and will continue to improve our understanding of these elusive particles until Dune begins operations. In parallel, 3 short baseline neutrino experiments at Fermilab are searching for signs of new physics using liquid argon-based neutrino detectors, contributing to the development of this technology for its future use in Dune. The short baseline neutrino program is an international collaboration with global contributions, including the Icarus detector that was originally built in Italy, refurbished at CERN, and then rebuilt at Fermilab. Together, the experiments will measure neutrino interactions with argon, search for signs of a fourth type of neutrino, and more, while advancing the state-of-the-art in neutrino data analysis in liquid argon detectors using AI and machine learning techniques. These efforts are not just advancing neutrino science, they are fostering an active community of neutrino scientists that share Fermilab as their common ground at the center of these activities. Community building is part of Fermilab's legacy and will continue to be critical to successfully realizing its future. The community that calls Fermilab their home away from home includes not just the users of the Fermilab Accelerator Complex. Another 2,300 researchers worked at Fermilab in the year 2022 on other world-leading projects. Building on its past as host to the communities who participated in fixed target and tevatron collider experiments, Fermilab is now the center of gravity for US physicists on the CMS experiments at the LHC. Fermilab hosts the CMS Remote Operations Center, a Tier 1 computing center, and the LHC Physics Center, providing support for those involved in detector operations, data analysis, and physics activities. The recently completed Integrated Engineering Research Center, IERC, provides new space for communities to grow, particularly as Dune comes online. Fermilab has also established a presence in South Dakota to manage LBNF FARSA activities with the South Dakota support divisions. As new domestic and international users and affiliates join Fermilab-hosted efforts, the laboratory must continue to provide them appropriate access in a seamless fashion and enable them to use all of the lab's capabilities. This will be critical as the Dune program ramps up in the future, potentially doubling the number of laboratory users. While particle physics is the foundation of the laboratory's program, Fermilab is also attracting people to advance related fields. The Superconducting Quantum Materials and System SQMS Center at Fermilab is one of 5 research centers funded by DOE's Office of Science as part of a national initiative to develop and deploy the world's most powerful quantum computers and sensors. SQMS brings together over 400 experts from 28 partners, including national laboratories, academic institutions, and industry, to develop beyond the state-of-the-art quantum computers and sensors by applying technologies developed for the world's most advanced particle accelerators. Fermilab's expertise in superconducting RF cavities is being applied to the development of ultra-sensitive quantum probes. The laboratory's capabilities in material science, sensor development, and quantum theory are being leveraged to develop better quantum devices, better technologies for quantum processors, and new applications for quantum computing platforms and quantum sensors. These new tools can be applied to challenges such as ultra-sensitive dark matter searches today, with vast potential to revolutionize a number of scientific research areas tomorrow. Together with partners, Fermilab is advancing the field of quantum information science while training the next generation of quantum researchers and engineers. As a national laboratory, Fermilab has 4 core capabilities that support the Office of Science mission: particle physics, large-scale user facilities and advanced instrumentation, accelerated science and technology, and advanced computer science, visualization, and data. The SQMS Center shows one way that the laboratory's capabilities can be leveraged to tackle emerging new fields, even as it continues to be a global leader in more traditional areas of particle physics. In addition, artificial intelligence and machine learning are deeply embedded in the laboratory's efforts and are another area that the Office of Science recognizes as a key cross-cutting effort tied to a national initiative. Fermilab is playing a leading role in applying AI to problems that could broadly benefit science, including embedding AI in front-end detector electronics for real-time analysis during data acquisition and using AI to tune and improve particle accelerator performance. The Office of Science also recognizes a critical need to address challenges in microelectronics necessary to advance scientific discovery through the next generation of scientific facilities and advanced computing resources. Fermilab is in a position to leverage its capabilities to contribute to these cross-cutting challenges while also benefiting from the breakthroughs. In summary, Fermilab is at an exciting inflection point, carrying significant responsibilities while also ripe with opportunities. It faces the challenge of successfully delivering projects that are foundational to both the U.S. strategy and the global portfolio for particle physics, including LBNF Dune and PIP2, which have a combined total project of $4 billion. It is in this unique position of being a single program laboratory that is also a substantial fraction of Office of Science high-energy physics program budget. Fermilab also plays an important role within the national laboratory ecosystem, hosting a DOE National Quantum Information Science Research Center and providing advanced technology to other user facilities, such as accelerated components at SLAC National Accelerator Laboratory and Oak Ridge National Laboratory. The process to develop the next P5 report, which will define the U.S. strategy for particle physics for the coming decade, is underway. But we expect Fermilab will continue to play a central role for U.S. particle physics in the report's new global vision for the field. Managing all of the current projects and experiments, modernizing the site for sustainable and reliable operations for the future, recruiting and nurturing the diverse workforce that will be needed to capitalize on the compelling scientific opportunities, and coordinating a complex web of domestic and international partnerships will all present challenges, but also exciting opportunities for this laboratory in the coming decade. Building on its past successes, Fermilab is poised to launch into the coming decade with an even broader reach and impact to strengthen its standing as an international leader in science and technology. In closing, Building on its past successes, Fermilab is poised to launch into the coming decade with an even broader reach and impact to strengthen its standing as an international leader in science and technology. And we at DOE's Office of Science look forward to working with Fermilab to build and secure a bright and promising future. Thank you.